Let's finish up that last example in your 2.4 packet. Before we do, so things we need to know. If I want to find the slope of a curve at a particular point, I'm going to use the difference quotient, f of a plus h minus f of a over a plus h minus a, and let h get closer and closer to 0. Once I know the slope, after I evaluate that limit expression, I know the slope, and I can find a point by plugging the a value into the function to get the y value that goes with it. So then I'll have an ordered pair, and I'll know the slope, and I can use point-slope form for the equation of the line. If I am asked to find the equation of the line normal to the curve at a given x value, all that means is I want the line that's perpendicular to the tangent line. I'm going to use the same ordered pair in the equation, but instead of using the slope of the tangent that I find with the limit expression, I'm going to use the opposite reciprocal of that slope to get a line that's perpendicular. So check this out. So in this example, I'm asked to find the slope of the curve, f of x equals 1 over x. And instead of being asked to find the slope at a particular x value, I've been asked to find the slope at an abstract x value, which I'm going to call a. I can still use the same process to find the slope. What I'm going to get at the end is a formula I can use to find the slope of the curve for any x value. So watch what happens. I'm going to start with the limit expression for the slope of a curve at a point. The limit as h approaches 0 of f of a plus h minus f of a all over h. So I've written here, if I plug a plus h into the f function, 1 over x, it's going to get 1 over a plus h. And then f of a is just 1 over a. We practiced that on the last slide, so I'm here. Now, if I try to just plug in 0 for h, I'm going to have my 0 in the denominator problem. So I'm going to try some of the techniques that we used when we talked about limits in 2.1. One of the techniques that works, probably the first one we might guess to try here, is if I find a common denominator, so I can change this to multiplying a fraction in the numerator by the reciprocal of the fraction in the denominator. So I have 1 over a plus h and 1 over a. I have a common denominator in that big numerator of a times a plus h. So I'm going to multiply the first little fraction by a over a, and the second fraction by a plus h over a plus h. And now in the numerator I have a common denominator. So here we go, the next. Now if you're looking up here, I have a common denominator, which means all I have to do is subtract those numerators. I need to subtract a minus a plus h. This is a good time to remember what we practiced before, which is if I have an expression after a subtraction sign, I'm going to need to distribute the subtraction. So a minus the quantity, a plus h, is like a minus h, which is how I end up with this negative h here. And what happened to my denominator? Instead of dividing this whole mess by h, I've changed to multiplication by 1 over h. So if we look here, I'm going to be able to get around my division by 0 problem because now I have a negative h in a numerator, cancels with this h in denominator, leaves behind negative 1. So a negative h cancels with a positive h to leave behind negative 1. And I can simplify. I have now the ability to plug in 0 for h. So just notice this is going to be negative 1 over a times a plus 0, which simplifies to negative 1 over a squared. So my result, the slope is negative 1 over a squared, is the slope at any arbitrary point, at any arbitrary x value on this curve f of x equals 1 over x. So in part B, when I'm asked to find the slope of the curve at x equals 2, all I have to do is say, well, now I know what value to plug in for a, and my slope is negative 1 over 2 squared. The slope is negative 1/4. Now here in part C, I've been asked to write the equation for the tangent line. To write the equation for a line, I need a slope. I just computed the slope. M is -1/4. I'm also going to need an ordered pair. I've been given an x value. Now I need the y value that goes with x equals 2. So I'm going to use my function rule. I want to find f of 2. Well, this function, you find the y value by dividing 1 by your x value, so 1 divided by 2. And now I have my ordered pair, which is 2, 1/2, which is the ordered pair that I've used in the point-slope formula here. If you'd like to distribute and rearrange things to change this into slope-intercept form, you're invited to, but it is never, almost never required. So feel free, especially on my tests, to leave your answer in point-slope form. This answer would get full credit. And for part D, the only difference is we've been asked to find the equation of the normal line. Remember, that's the line that's perpendicular to the tangent line through the same ordered pair. I'm going to use that same ordered pair 2, 1/2 as my x1 and y1. And now the opposite reciprocal of my slope of -1/4 gives me a slope of 4. So you can see that I have used the slope 4 in that equation. So final answer.